All right. Hello, everybody. Welcome back to Comp 2450. Today, what I want to do is talk about this term. Today, what I want to do is I want to spend a little bit of time talking about Comp 2452. So what we talked about last class was kind of like, this is what we've done in this course, and ultimately, like, here's the big picture. We've got this idea of software architectures. We've got this idea of design patterns. This is what these big ideas have ultimately allowed us to accomplish in Comp 2450. But I'd also like to look ahead to Comp 2452 and see kind of more immediately what we're going to be taking a look at throughout the rest of that course. I want to spend a little bit of time telling you about the final exam, and giving you a chance to ask some verbal questions about the final exam. Just for transparency about the final exam and about asking me questions about the final exam, my strong preference is to answer questions about the final exam in a place where everybody can hear the answer that I'm giving to them. I don't really like the idea of somebody kind of coming to my office hours and asking me and then having some unfair advantage that nobody else is able to get. So I may politely ask you, if you're asking me in my office about the final exam, to either ask in class or to post the question on the discussion forum, and I'll be able to answer it there. But I do want to spend a little bit of time talking about that today to give you some idea of what's going to happen with that. And then the last thing I want to spend some time doing is to do a little bit of review. So I asked you last week to rank in order the things that you wanted to have a little bit of extra time to take a look at today. And so what I've put together today is to spend a little bit of time taking a look at testing some more. So I want to spend some time thinking about how we might test an abstract data type like a queue, and I want to focus on setting up test data for that. I don't want to do the mechanical test harness stuff because it's a mechanical test harness. It's basic Java code, but I do want to spend a little bit of time taking a look at that. And then I also want to spend a tiny bit of time, if possible, given the time that we have in the class, to take a look at the single responsibility principle and the dependency inversion principle again. Okay, so good morning, everybody. Welcome to Comp 2452. This is the lecture you're going to see when you show up in my class next term, or at least like part of the lecture that you'll see at the beginning of the class next term. What I want to be able to do by the end of today's tiny lecture inside of a lecture, and I want to put a very strong caveat that this is all tentatively right now. I have a lot of finalization left to do for this course, so like, stuff might change. I'm not going to promise this is exactly what we're going to do, but I want to give you some idea of what things might look like in this course. So I want you to be able to know what programming language we're going to be using in Comp 2452. I want you to be able to have a sense of the environment that we're going to be using in Comp 2452. I want you to have some idea of the kinds of the learning outcomes that you're going to expect to see and that you should expect to be able to demonstrate by the end of the course, by the time we're all done. Putting this into context, the language and environment that we were using in Comp 2450 was Java. This is a language that you are all now pretty familiar with at this point. You've been using it in lots of different courses. And we've been using it extensively in Comp 2450 to be able to implement the projects that we're working on. And we had an entirely text-based, and I'm going to call this a discrete event sort of interface. Everything was happening with input based on scanner. We were typing stuff in, we would press enter, some processing would happen in the background. We would print some results out as a result of that. Everything was in this tiny box that showed up at the bottom of our IDE. And it was, again, kind of discrete. You type stuff in, you press enter, stuff happens. You're asked for more information, you type stuff in, you press enter, more stuff happens. We were also doing text-based persistence in this course. So when we actually got to doing persistence with the domain model that we'd put together, we were taking that domain model and transforming it into strings, into JSON objects, into JavaScript objects to be able to do some persistence and then loading it back up again. We also used a layered architecture, and so we had this 3-tier architecture at the end where we had our user interface layer, we had our logic layer, and we had a persistence layer. In Comp 2452, we're going to start doing GUIs. So welcome everybody to 1985. We're going to move past text-based and terminal interactions. We're going to start doing some GUI stuff. The programming language that I'm planning to use for this course is TypeScript. In Comp 2400 right now, you're using JavaScript, ? Or you have used JavaScript at least, yeah. TypeScript is an extension of JavaScript that has actual types. So it has things like interfaces, and it has things like proper classes, and it has things like support for checking to see at compile time if an object has a method, for example, unlike what you can't do in JavaScript right now. TypeScript is a language that is compiled to JavaScript. And so what that means is that you will write code in TypeScript, and then at some point you will use a build and dependency management tool to take this TypeScript code and transform it into JavaScript. We're going to be using GUIs, and to do GUIs, we're going to be using the web browser, but this is all going to be local. We're not going to be doing any kind of web programming here. I'm not going to be asking you to set up web servers. Everything is going to be fully contained within your web browser. If you're not connected to Wi-Fi, you should still be able to do everything that you need to do with your app. It's just going to be that the web browser is the environment that we're using for this course. We are going to use a build and dependency management tool. I assume that in 2400 you're using Node for JavaScript. Yes, okay. And have you used NPM at all for doing anything? Okay. So you're going to use Node again for this course, but we're going to actually use a build and dependency management tool. NPM is the package manager that comes with Node. If you've installed Node on your machine, you should already have NPM installed. NPM is a lot like what Maven is in that it's responsible for building JavaScript projects, but it's also doing dependency management. So you'll be able to install dependencies using NPM. The setup for NPM is a little different than Maven, where Maven, what we're doing is like, we've got this POM file and we're copying and pasting fragments into this XML file to add dependencies to our projects. With NPM, it's more of a command line driven, like I want to install this dependency into my project, and I am going to, NPM will manage the file itself for setting up the dependencies that you've got here. NPX is a tool that will help using NPM. NPM, when it installs things, it also sometimes installs extra little programs, but only into its own little area. NPX kind of sets up your environment on the command line so that it has access to all of those things, and you don't have to worry about setting all that stuff up. So we're going to continue to use build and dependency management tools. They're just going to be a little bit different in Comp 2452. We're not going to use any kind of web application frameworks. We're not using React, we're not using Angular, we're not using Vue, we're not doing any of those kinds of things. We're limiting ourselves to TypeScript as a language, and we're going to impose an architecture upon ourselves as opposed to using an existing framework. As you get into future courses, so again, Comp 3020 is human-computer action. You might be using a framework in that course. In Comp 3350, for sure, in Software Engineering 1, you will definitely use a framework in that course to construct an application with Android or with some kind of a web application. You will use an application framework there. But in Comp 2452, we're not going to be using any application frameworks. We're just going to be building this up kind of from scratch as opposed to using any kind of frameworks. We're going to use actual SQL for persistence in this course. So that means that we're going to actually have to learn how to use SQL as a programming language. And we'll also have to set things up so that we have a persistence mechanism. And the mechanism or the tool that we're going to use for that is something that's called SQLite. Again, this is all local. We're not going to be setting up web servers. We're not going to be setting up database servers. SQLite is a way that we can have SQL fully embedded within our application without having to connect to other servers to be able to accomplish the tasks that we want to accomplish. We're going to use for our graphical user interface HTML and then optionally CSS. I'm almost certainly not going to talk about CSS in this course. I'm not going to stop you from using CSS if you want to, but that's not something that's really important. Our apps are going to look like garbage, let me tell you that. And I welcome you to make a pretty looking app with CSS, but I don't care. That's not going to be an outcome for this course. I don't care how good it looks. It's just going to be basic HTML that we're looking at here for this. And we're also not going to use Canvas. Canvas is a way for you to do like arbitrary drawing on the screen. We're not doing that sort of thing. If you're taking, I heard some people talking about the game course next term, you'll get some of that in that course, but that's more 3D than 2D, where Canvas would be more of a 2D application. But we're fixing ourselves here to HTML and TypeScript. We are going to use a test framework. I don't really want to spend any more time writing these mechanical test harnesses. You should, at this point, have a sense of the idea of coming up with test data, and you should, at this point, have some idea of like what a test harness actually does in terms of running your tests and collecting information about your tests and reporting at the end what your tests failed or succeeded. We're going to just actually use a test framework to do that for us now, so we can focus on just writing tests for the stuff that we're going to be doing. I'd like to take the time to take a look at the course description for this course. And the way that I'm going to do that actually is I'm going to show you where all the course descriptions are for all of our courses, just in case you haven't seen this listing of course descriptions before. So I'm going to go to the CS homepage. This is www.cs.umanitoba.ca. And what I'm going to look at here is just along the right here, there's this course offerings link under the what we offer section. And I don't really like the way that this page is laid out. And I look at it, I don't know, somewhat frequently, actually. I don't like the way that this page is laid out. This is just a list of the courses. I think it's redundant to have this here, but this is now me criticizing the Faculty of Science people who are responsible for making this page. The actual thing I want to see here is this, these undergraduate course syllabuses or syllabi. So this is where you can find all of the course descriptions for every course that we offer as an undergraduate course in our department. I will quickly pop open these two because I love these courses, and I'm super biased about this, but I love these courses. These are the lab courses. This is where you're going to find things like learning about how to do version control and stuff in the context of a course. But the one I really want to take a look at here is Comp 2452. I'm going to zoom in a little bit on this. So the focus here for Comp 2452 is that we're going to be building upon what we've done, again, in Comp 2450 in this course. So the things that I want to be able to do is to start thinking about the applications that we've got right now and starting to think about how we might change those things based upon the things that we've learned in this term. So things like what you've done in Comp 2400 and the stuff that we've done in this course. I want you to use testing frameworks. I want you to be able to use a database, an actual proper database to do this. Using AI algorithms here, this is going to be a very basic idea. I don't want to get your hopes up and say that this is going to be some machine learning thing. This is going to be a really, really basic kind of machine AI, introduction to AI in terms of like decision-making algorithms, as opposed to something complex like statistical models to represent things. That's not something that we're going to be doing in this course. And then we will be spending some time taking a look at methods, principles, and heuristics for evaluating user interfaces. So as we step up from from text-based UIs to graphical user interfaces, we have to have some way of deciding whether or not this is going to be usable by an actual person. Again, it's going to look like garbage, but it might be usable garbage. Yes, I want to say it that way. It might be usable garbage versus unusable garbage. And that's totally fine. We're going to spend more time talking about software design stuff. One of the things that we haven't talked about in this course is coupling and cohesion. We haven't talked about this directly, but a lot of the stuff that we've been doing in this course has been about these two ideas of coupling and cohesion. And this is really about kind of like interdependencies of different parts of the software that you've got. I want you to be able to continue to write unit tests and use test suites and frameworks. We're going to be doing database stuff here, so I will want you to be able to do things like taking domain or data model objects and putting them into a database. We're going to be using SQL to accomplish all of this stuff. We're going to spend some time thinking about secure programming practices and what are reasonable things to do when you're thinking about stuff like, I've got a password in my database. Keeping it in plain text is probably not the right choice, because if anybody gets hold of that thing, you've leaked your passwords all over the place. JSON is a terrible way to store that, especially if it's just a plain text version of the password that you've got. We'll also spend a little bit of time talking about this idea of SQL injection. I'm going to leave that for Comp 2452, but it's kind of a fun thing to take a look at here. And then the last part of this is we're going to spend a little bit of time thinking about, again, how do we evaluate these graphical user interfaces? Again, it doesn't have to look great, but it has to be usable. And we want to be able to evaluate that using some kind of an objective approach. And then again, the very last part here is about AI stuff. And again, I'm really sorry for saying again so many times today, but this is just basic AI stuff. We're not going to do machine learning. It's going to be just primitive decision stuff as opposed to complex statistical inference engines and that sort of idea. All right. Does anybody have any questions about Comp 2452 before we proceed into doing final exam stuff? Yeah.
Well, Comp 2452, since we're working with a new suite of tools, we're probably not expected to, like for assignments and things, are we like getting a project that you built from scratch for us to evaluate, or how does that work?
So for now, we're going to be building up a project from scratch again, but we're not necessarily going to be doing it in the same order that we've been doing it with this course. In Comp 2450, we kind of started doing each layer one at a time. So we started with our domain model as like, this is the common thing for all layers. Then we added the logic and UI layers, and then we added a persistence layer. In this course, what I am planning for us to be doing is more of a feature-based approach than a layer-based approach. So here's what I want you to accomplish in this task. You'll need to build all those parts. As you proceed in the course, you may need to go back and make changes to those existing parts based on new stuff that we learn. I can't teach you all of GUI and SQL and in the first week of classes. So you'll have to go back and make some changes to things, but I'm also planning to try and structure it so that that's minimized in terms of like having to go back and change features. Yeah.
For this project, do you still have the same kind of mastery setup for phase?
That's an excellent question. I haven't committed to that idea yet, but that is my plan. I'm also planning to try to have smaller deliverables throughout the course as opposed to having bigger deliverables like we've had in this course. And that's something that we'll take going forward even in this course. We'll probably just have smaller deliverables rather than bigger deliverables like we've had this time. But yes, and I think that's important. To me, that's important because in a lot of cases, what we're doing with one deliverable to the next, to the next, to the next is trying to make sure that you're going to succeed in all of them. And that's really what that's meant to be about. Yeah. So the short answer to the question is yes, probably we're going to keep doing that. Yeah. Yeah. Are you using VS Code? I very much welcome you to use VS Code for this course. Yes. That was like, oh, thank God. That's what I saw in your face. I'm probably going to use Vim. I'm not going to teach you how to use Vim, but if I'm doing any coding in class, I'm probably going to use Vim in this course. Because that's the text editor that I like to use. With TypeScript and JavaScript and HTML, this is me being an old person now, I think. That's just how, when I was when I was a young lad, that's how I did HTML stuff, was with basic text editors. I didn't have a proper IDE for this stuff. When I started doing Java, I definitely had an IDE. I used Eclipse for many, many years. IntelliJ is so much better than Eclipse ever was, for the record. But for TypeScript, for JavaScript, and because NPM and NPX are more command line tools, I'm more comfortable in that environment, so I'll probably be using Vim for that. But yes, I welcome you to use VS Code for that course. VS Code, also for the record, has built-in TypeScript support. I don't even think you need to install an extension to get TypeScript support in VS Code. You have to have Node installed, and you have to install TypeScript as a tool in Node. But once you've installed it, it's TypeScript support, I think, is just built into VS Code. Yeah. Any other questions? All right, okay. So let's talk about our final exam. It's 2 hours. It's been scheduled by the registrar's office. I put a link here to the final exam schedule on the registrar's office webpage, so you can take a look at that if you want. The seating for this final exam is going to be assigned. So the way that this is going to work is that we're going to send you an email the day of the exam. So in the morning on the, now I'm going to go back to the registrar's office webpage, so I'm not making stuff up here. On the morning of the 16th of December, you should expect to receive an email in your inbox that tells you what seat you're going to sit in and what room you should go to. On the registrar's office website, there are 2 sections listed. There are 2 sections of this course this term. The 2 sections that are listed here are 200 education and 290 education. These rooms are very close to each other. They're in the same building, and the exams are scheduled at the same time for both sections. But the room that you see here for us, 200 education, is not necessarily where you are going to be told to sit. The email that tells you what room to go to is the thing you should trust. This seating is going to be assigned, and your name will be printed on the exam when you show up. So you must sit in the place that has your name printed on it. We will publish kind of like layouts of the room as best we can to make sure that you know where your exam approximately is going to be located before you show up to the exam. And if you've registered to write your exam in an alternate location with Student Accessibility Services, you should just expect that when you show up to the Student Accessibility Services exam, that they will have the exam that has your name on it already. So you'll still get this email, but you should just go to wherever it is that you're supposed to go to with Student Accessibility Services for that. Yeah, the room may not match what's on the actual exam schedule here. The format that you're going to see on this is consistent with the quizzes. The scale of the question is going to be different in terms of, we've got 2 hours here as opposed to the 5 and 10 minutes that we've been looking at for all the quizzes that we've got. I have been publishing blank copies of the quizzes up on the course webpage for our section. The other section's instructor has promised to do the same thing, so there will be another set of quizzes that have slightly different questions that you will have available for you if you want to practice. I also still have a very limited supply of printed blank quizzes. I will bring those to class on Friday this week, and I'll just lay them out on the table here if you want to have a printed copy of those blanks, if you don't have a printer at home or if you just don't want to print something out. But they're otherwise available up on the course webpage. We may ask you to write pseudocode on this final exam, but in no way am I going to be assessing Java syntax. I don't care. You have an IDE, your IDE helps you. It doesn't matter to me if you miss a semicolon or if you miss a curly brace or if you put protected in the place where public is supposed to be. Your code might not compile. I don't really care. I'm looking for like major structural things in terms of what we talked about in this class so far. Yeah.
When you say pseudocode, is that still approximately like a line-to-line thing, or is it like you can write, well, this
That's a good question. Pseudocode to me is like still using programming language structures like for loops, and like I'm saying this is a class, for example, and not just English text that describes an algorithm. Yeah, yeah. But we're not going to require you to write Java syntax. If you want to write Python, awesome, I guess. But yeah, we're looking more for just an idea of what it is that you're trying to accomplish. That said, I may expect you to read Java code. I might provide you with printed Java code and ask you questions about that Java code. And in that case, if I'm giving you Java code, I expect you to be able to read Java code. The course learning outcomes. So these are the things effectively that I've been putting into the slides for every single lecture at the very beginning. These are the things that I want you to be able to do at the end of this class. These course learning outcomes are what are examinable where it's appropriate. So as an example of something that's not appropriate for us to examine on a written final exam, I can't really assess you on using a build-in dependency management tool on a written final exam. I don't want you to have to memorize like how to run Maven. I don't want you to memorize at all how to add dependencies to a Maven project. Because all we've done in this course and all I've demonstrated to you is, here's the web page, copy and paste this block. I can't assess that meaningfully on a final exam. So that's not something that we're going to assess on this final exam. The things that we're going to be assessing are where they're appropriate. To that end, once we've prepared the final exam, after we've finished preparing the final exam, we're going to publish on the course webpage a list of the learning outcomes that are actually on the final exam. We only have 2 hours. We can't comprehensively necessarily assess everything. And so I want to give you some indication of what is actually going to be on the final exam to help you kind of focus your preparation efforts for that final exam. That's all I have to say for now. So I will open the floor again to any questions if there are any. Yeah. I'm gonna walk back the word greatly expanded. That implies like one question that was 5 minutes is now 10 hours. Somewhere in between, yeah. So let's think back to one of the first quizzes we gave you was about coming up with an appropriate class diagram to represent a problem. And the thing that we were looking at for that was approximately three things in this core idea. I mean, a reasonable way to expand that might be to expect you to go up to like 5 or 6, maybe 7 or 8 different ideas in this description of a thing. But we also have to take into account the amount of time it takes you to actually read something that represents that complex of an idea. That's not a concrete example necessarily of the kind of scaling up that we might be doing, but I hope it gives you an idea of what I mean by scaling up. Okay, yeah. That's a very good question. In terms of persistence in JSON, I will remind you again, I don't care about JSON. Like, please do not spend any time trying to memorize what JSON is at all. In fact, I'm going to go as far as to straight up assert that the word JSON will not appear on this exam. The word JSON might appear on this exam, but it's not going to be like, hey, write this JSON object for me. That's not something I care about. The things that we focused on when we were talking about JSON and the things I want you to think about when we were focusing on JSON was really about the idea of layers of responsibility. So separating concerns into these different layers of responsibility, and dependency inversion and dependency injection. Those were the really big ideas that we were focusing on. JSON happened to be a specific implementation that we were using for the purposes of this course, but it's really just a means to an end. I could have just as easily asked you to use CSV for this project instead of JSON, but I don't want to do that. JSON is cool. JSON is cool, but I don't care about JSON in terms of assessing you on anything about that. Does that answer your question?
Just a little bit on top of that.
is it writing the persistence method, for example, saving or loading? Would that be an expectation?
So that's another good question. So the question here is about writing persistence methods related to saving or loading. The thing that we can think about there that's not hyper specific to JSON is, while it's related to JSON, it's not specific to JSON, is the idea of how composite and aggregate relationships inform the kinds of decisions that we're making about what to persist for each of those things. So looking ahead to Comp 2452, and I know this is outside the scope of your question, but looking ahead to Comp 2452, right now with JSON, we've got this idea of if I want to persist two objects that have a composite relationship, one instance owns this other instance, then this JSON file will have that instance plus the full instance of the other thing embedded inside of it. That's the kind of structure that we're looking at with this. That informing of how the persistence works is still going to be true for SQL. It's going to be different. We're going to have different tables. They'll be physically separated from each other, but we're going to set things up such that if you delete this record, it will cause other records to be deleted from other tables. If you update this record, it won't necessarily update this other thing, but it's possible that it could update this other thing. So the saving and loading of stuff, the thing that is relevant to something you might want to consider on a final exam is about how those relationships inform what you're doing when you're doing it. But again, no, like nothing about using JSON Builder to construct an object and then fully materializing this other sub-object inside of it. That's too granular for what we're thinking about for a final exam. Yeah. Yeah.
Any estimate on when the document with these learning outcomes will be posted?
The latest that I would expect it to show up is going to be, I'm looking at my calendar because I never know what day it actually is anymore. The very latest that I would expect you to see this is on Friday the 12th. I would want to have the exam printed before that day. So that's the day that I'd say is the latest you should expect that to show up on the course webpage. Yeah.
Some of the exams cover material later in the term that we said about this exam.
Later in the term
I mean, yeah, the topics that are covered later are usually, they're like a focus in them.
So that's a good question in terms of like the emphasis of certain course materials on the final exam. In other courses where you have term tests, often the focus will be on the things that happened after the term test as opposed to before it. But we didn't really have term tests in this course. And so I'd say that you should at this point expect most things to be approximately equally likely and equally weighted across the whole exam.
Would just the quizzes be a good practice of it?
I think the quizzes will give you a good idea of what kinds of questions you might expect to see on that exam. Also, the learning outcomes document that should give you an idea of what we're expecting you to actually be able to demonstrate to us. Yeah.
Did the other section get those guest lectures as well?
Dr. Chowdhury came to their section, yes. They didn't have one with Seth.
Maybe would be like something regarding what they did.
I often put bonus questions on my exams, yes. The bonus questions are usually bullshit questions, as opposed to like something actually directly related to the course, though. Yeah. Hey, I still can't answer questions about what Walter looks like in the final exam. Yeah. If we were to ask you anything about those guest lectures, it would be very similar to what you saw in the quiz that we wrote. Yeah. Any other questions?
The feedback that we see from all phases also help us.
The feedback that you see on your phases yes, in some cases can. So like a real common piece of feedback that I see as I'm reviewing things and as I'm going through grading myself is about the single responsibility principle. Kind of making sure that your different types of classes are doing just the thing that they're supposed to do, as opposed to things like printing is often the common thing that shows up there. The other kinds of feedback that you did receive about like making changes to your domain model, those might be reasonable things for you to consider, yes. Yeah. The grading is coming along. I was going to publish more yesterday, but I had a fully committed day yesterday, and I just wasn't able to get anything more out. So there are some cases where we're hitting 2 weeks, but as far as I know, we haven't been exceeding 2 weeks lately in terms of response time. In fact, in a lot of cases, I think we've been publishing in much sooner than 2 weeks. Again, if you're still in a situation where you've exceeded 2 weeks, this is not to you anymore, but to everybody, if you're in that situation of having exceeded 2 weeks, please let me know as soon as you can, and I'll do my best to get that feedback back to you. Yeah. All right, okay. So we got about 10 minutes left, so let's spend a little bit of time doing a tiny little bit of review. The first thing that you kind of ranked highest was this idea of software testing, and then the second ranked thing was design principles. In terms of we've only got about 10 minutes left in the class, I think we'll probably only be able to talk about software testing today, but I've got a couple of things that I'll gesture wildly at when we get to this idea of design principles in terms of other resources that you could take a look at for thinking about design principles. So to review the idea of software testing, I want to talk about two major things. The first is I want to think about the idea of testing a queue using just its interface, so just an abstract data type, just the interface. And this is kind of related to and similar to the idea of implementing tests for a set. And the other thing I want to think about here is testing a logic layer method. So in class, I kind of came up with this complex data structure and data set for this logic layer thing without spending a lot of time dwelling on the idea of coming up with the test data itself. And so I want to spend a little bit of time thinking about that. The focus here is going to be on two main ideas. I want to generate test data for these things. So what exactly are we expecting to put into a test case? And then what exactly are we expecting to get out of that test case? What observations and expected outputs can we expect to see when we run or write a test for some specific behavior given these specific inputs? This is the interface that I want us to consider right now in terms of assessing its behavior. So this is a small or a simplified version of a queue interface where we've got two major operations. We've got NQ and DQ. We've also got a peak operation, so we can take a look at what's at the front of the stack right now, at the queue, sorry. And we've also got a size operation to be able to ask how many elements are on this queue right now. There's this idea of a queue and empty queue exception. So when we try to do things like peak or DQ from this queue when there's nothing on it, then we should expect to see this exception being raised as a result of that. I want to focus on generating test data. So we're going to do this in a spreadsheet. I don't want to open IntelliJ today. I don't really want to write any code for this. I want to focus on the idea of generating test data for this interface and figuring out what the expected outputs or observations are that we can make from each of these different test cases that we've got. So I'm going to pop open my spreadsheet software. I've also posted this spreadsheet up on the course webpage if you want to follow along with me, but I will promise to put the populated version of this spreadsheet up on the course webpage after today's class as well, so that you'll have a copy of both of these things. For us, for convenience, I've put the stack interface directly into this spreadsheet. And now I want to spend a little bit of time thinking about the test data itself that we'd have for this. So when we initially talked about testing abstract data types, and when we initially talked about testing this idea of testing in general, one of the things that I mentioned to you was this idea of having our tests be independent from one another. So I want one test and the result of one test to not really have an effect on the other tests that I have in this thing. When I'm thinking about that in terms of testing an interface and an implementation of an interface, generally what I mean by that is when I'm testing the NQ method or function here, when I have a test for that, the test is going to start with a fresh instance of that object. When I have my next test, I'm going to make another new instance of that object. When I have another test, I will make a new instance of that object. I don't want the test for one thing failing or succeeding to cause the next thing to fail or succeed. If my NQ is buggy, I don't want that necessarily to affect the outcome of something like size. If my size is buggy, I don't necessarily want that to affect the results of my DQ test. When we're doing these, they'll all likely fail, but I want to see the different results of those failures so that I can get a clearer idea of what it is that's failing as a result of that. Yeah.
Each expected behavior should be about that single method, or it can be about multiple methods that are related to whatever we did.
So the question is about do the expected behaviors or outcomes apply just to that method, or can they be about other methods? In the context of an interface like this, the only way we can make observations about this internal state of this object is by asking other questions with the other methods that are on it. For me to be able to test NQ, okay, so let's actually do that test right now. I want to test NQ, and I'm going to be testing this on an empty stack. So I'm going to start with an empty stack. And I'm going to NQ a string, let's say 10. I'm going to put this string on it. In terms of testing this interface, the only way I can make direct observations about that NQ has worked is to ask things like, does peak returns 10? Does size return 1? My size should be 1 bigger after I push something onto this. And ultimately, does DQ return 10? So in order for me to make those observations, I have to be able to interact with those other methods, because the interface here doesn't tell me anything about how it's implemented. If I was testing a specific implementation of this, so if I had a linked list queue, then I might be writing a test that says, does head equal this now? But in terms of just testing this, and I don't necessarily have access to the source code or the underlying implementation of that, I want to focus on these are the observations I can make based on the interface methods that are provided to me.
Like, as you said, we shouldn't have some particular test affecting the other. So in this case, those small stuff tests here, for example, calling size before calling DQ. And if that size method is buggy, and because of the size method, now DQ doesn't work properly, for example, doesn't that mean that testing size affected the test for DQ?
We're not testing size here, though. The thing that we're testing in this specific case is NQ. The side effect that I'm expecting to see is that size has become 1 bigger. You're right, if size is not implemented correctly, it's going to fail on size is not 1. But the thing that I'm writing for this specific test is I'm trying to test the behavior of NQ itself. Calling DQ after I've called size, I could again test to see does size equal 1, equals 0 after I've called DQ, but now I'm starting to evaluate the behavior of DQ itself as opposed to the behavior that I wanted to assess with the NQ operation. Yeah.
I can put this another way, make sure I get it.
Yeah.
Our tests may have some overlap for like our NQ test size and our size test NQ. But our NQ tests, we write them all that way to make sure that we're testing everything for NQ and maybe it's an extra, and then our size is testing everything for size and maybe it's an extra instead.
That's kind of the idea, yes. I want to write a test that's going to interact with NQ, whereas that's the primary focus of what my test is, to call these other methods to make observations about it, but that's not what my test is actually about right now. I will call then later NQ to verify size, but I'll have to do that in a separate test. But my focus on that one will be about size, and I'll be calling this NQ method to change its internal state to be able to do that. Yes, Umang.
So when you talk about independence, if you would have called DQ at the very first, just for the empty stack, then the other methods could have failed.
When I'm talking about independence here, what I mean is if I call NQ with an empty stack, and then I pass 10 times 100, then I should be able to peak returns 10, size returns 100, DQ returns 10. But for each of these two test methods that I'm going to write, I'm going to use a different instance of this Q implementation. That's what I mean by that. So test 1 here is going to have new linked list Q. Test 2 is going to have new linked list Q, and they're going to be independent of each other. So this case here, where I have just one piece of data that I pushed onto it or NQ'd onto this queue, these are the outcomes that I expect. If one of those fails, I don't necessarily want it to affect this other test. In this case, it will almost certainly fail as well because something about NQ appears to be wrong, but I want those two to have different instances of the thing that we're testing.
So within the first one, like the empty stack testing, you intentionally do DQ at the beginning so that you can have peak size. Or if we do DQ at the
Well, if I did DQ before I did peak, then I would call peak and there'd be an exception. Yeah. So I'm trying to use this in the way that I'd expect it to be used. Yeah.
So in general, if we said that whenever we have an interface, then we can expect that our test will have those multiple methods that alternate.
Yes.
And with classes, it will always be the case that we test just a single method, and the expected thing is either an exception or the result of that method.
In as far as is possible, yes. When you have the implementation that you're assessing rather than just the interface, you can start to make other observations about its internal state. But even then, you might be calling accessors to get access to that internal state. So when I did that do attack test, I still had to call get battle state after calling do attack to be able to verify that. And so now I'm actually testing these things are working together. The state has changed after the battle is over. Yeah. Okay, so I'll write a couple more of these to give you some more ideas of what's going on. So those are two examples of what I could do with NQ. Another thing that I might want to NQ here is going to be an empty stack, but I want to test 1 and then 2 and then 3. So like putting things onto the queue in a specific order and then expect that DQing them, DQ returns 1 first, then returns 2. So it operates as a queue structure. The first in is the first out of this thing. So calling this repeatedly should give me the things I'm expecting to see here. And then the other thing that I'm going to test here is if I call peak on an empty stack, then the expected behavior that I would expect to see here is an empty queue exception is being thrown. So if size is nothing, then I'd expect peak on this empty queue to raise this exception for me. Yeah. Whoa, I'm very sorry. I meant to write Q here in all of these cases. That's my mistake for mixing data structures here in class. So all of these examples should be empty Q. All right, so I will publish this document up on the course webpage, and I'll put a couple more extra test cases in there. At this point, you should know a little bit more about 2452, and you should know more about the final exam. That's it for today. I hope you have a good rest of your day, and I will see you all on Friday. Bye, everybody. There is a quiz on Friday, yeah.